Hello, everyone. Today we will do a little excursion back into the field of Lyme disease and the co-infections. With all the hoo-ha that happened the last year and a half, the last 2 years, we got a bit distracted. I believe, and I know that for the last 20 or 30 years, we do have a pandemic, and it's called Lyme disease, a real pandemic. And so just briefly how I got into that field. I grew up originally I grew up in Berlin, which was fine. And then when I was 12, after the wall was built around Berlin, my dad panicked and moved us to a little town in the south of Germany on the French border. So with the idea, if the Russians come, we can swim over the Rhine River to France and be in safety. So that was but there were the estuaries of the Rhine River. There were a lot of stinging insects, a lot of ticks, a lot of all that. And as it turned out, until 100 years ago, was the highest area in the world with malaria, much more than in Africa. And so looking back, what is well known now, that it was a hotbed, this area, for Lyme disease, for Bartonella, for Babesia, for Rickettsia, for all those things. And so I was probably, first year I was there, fresh from the city into this little town where we mostly lived in the woods. And I probably had at least 100 tick bites in the first 2 years of, between age 12 and age 14, and endless spider bites and bites of stinging insects. And then, started slowly developing different problems that encouraged me actually to study medicine, because at the time there was no help given to anybody, And so in medical school, I had a professor, Professor Faust. He has a very traditional German name. And Professor Faust was considered a genius of his time. He was a neurologist and psychiatrist. And he had this incredible ability. He could go in a room full of patients and watch them for 2-3 minutes and kind of say, well, this guy over there, he is from Villingen. That's a little town in the Black Forest. And this guy is from Herdern, which is a suburb of Freiburg. And this guy is from there. And then assistants, we verified it. Are you really from there? Yes, I am. Are you really from there? Yes, I am. So I asked the professor, well, how the hell are you doing that? That you can look at people and tell where they're from. And he said, well, this area of the world has the highest incidence of insect-borne infections. And they all cause slight damage to the cranial nerves, the facial nerve that innervates the facial features, the vagus nerve, which changes your voice and your swallowing. And so all the cranial nerves play out in the face and shoulders to a certain degree. The details don't matter. And he knew when somebody was from a certain area in the Black Forest area, that there was a predominant type of ticks or predominant type of spiders carrying certain infections that would very specifically cause subtle neurological damage, which allowed him, after all these years, 50 years of working, to find out where people are from. Now, rolling the clock forward, this part of southern Germany and northern Switzerland and eastern France, that's a tri-country area, is known in neurology for 150 years for a hotbed of certain neurological illnesses, and always associated them with insect bites and the bacteria transferred by it. And so the nearest university is the University of Basel, Switzerland, that has the largest tropical illness institute dealing with these kind of infectious diseases. And one of the young assistants at Basel studied together with Professor Faust the impact of spirochetes transferred by insect bites this is going back to the 1950s and 1960s, where we're involved with the study of the effect of infections transferred by insect bites to people. And this young professor was Professor Willy Burgdorfer. He was this young assistant, and he became a docent, which is sort of like something under the professor at the university in Basel, and he was a professor for insectology, for insect science. I forgot the scientific name of it, and had a certain reputation and sitting on the microscope studying insects and doing really good work and publishing things. And so, rolling the clock forward, he got a call from America, offering him a position in the university in New York. That's how he got there. And as we now know from this wonderful book, whose name I'm not going to mention, an investigative report written by an acquaintance of ours, she did very, very diligent work. And he was actually hired, based on the forces behind the scenes that were running the biological warfare labs in the US, including Plum Island. And so actually it's the people that organized the research done on how to weaponize ticks and other insects. That research was done on the East Coast of the US, but now we know there's over 2,000 lab facilities in the US. And so Burgdorfer was actually not called there by accident, but he was actually with his knowledge, consenting to work with the lab. And then when the famous outbreak happened, where young people in Lyme, Connecticut developed swollen knees and very severe fatigue and fevers. And since it only happened on one side of the river and not on the other side of the river, the local physicians very quickly knew it was an infectious disease. And then somehow magically, Burgdorfer was called onto the scene, and he magically, based on his deep knowledge, knew that this was an illness caused by spirochetes, and an unusual brand of spirochetes that had new properties that gained that weren't known to the spirochetes that he remembered from Switzerland or from Germany. And so the assumption is, and I think that's pretty good proof, that he was actually hired with the same forces, that run biological warfare labs, branches of the military, and so so it wasn't like his genius that he suddenly found an infection nobody had seen, but he actually was a world expert, and he was actually involved in creating it, and he was a witness of it being released. I do believe it was unintentionally from the lab, and then slowly spread its way. The Plum Island and Lyme, Connecticut, I don't know how many miles there are, but you could walk it easily in a day. There is a little bit of water in between, but that recedes at low tide. You can actually walk from Plum Island to the coast so many days of the year. And so did the deer that was grazing there, and so were the rats, and definitely the birds that picked up things in the lab and then flew towards the mainland, dropping whatever they had. So there's a bit of a new tweak on the old story, how Lyme disease was discovered. And I certainly can tell you from 40 years or more of experience that there is two versions of Lyme disease. There is the one that I'm very familiar with from Germany that causes maybe some joint swelling and joint problems. And you see the old farmers and farming women in the Black Forest, they all have these big, huge knees, but they live until they're 96 or 102 years old. Now, the people in the US that got Lyme disease, they also got bad joints, they got muscle aches, and they got, however, fevers, which the ones in Germany didn't. And certainly the ones in Germany didn't get the fatigue. They lived with full energy until they're 100 years old. And then suddenly we saw this new brand of Lyme disease that did things that the old version didn't do. We historically also, we know one of the early findings of Lyme disease is 5,300 years ago. that was Ötzi. Ötzi is a brief name for a corpse found in what's called the Ötztaler Alpen. That's a part of Austria. Like the Swiss Alps, there's the Austrian Alps, and it's part of that. And there were a couple of hikers that found, as the glaciers are receding there, it thawed out this body, and these hikers found it. And one of the hikers was a friend of mine, a medical doctor. And so we were in touch at the time. And so he knew that he'd found something incredibly precious. As it turns out, so he worked with the government and took the body and refroze it and then examined it in different ways. But he retained the right to participate in the research as a condition of disclosing what the body was. And so being in contact with me, guess what we had the corpse tested for? The corpse turned out to be 5,300 years old. And it was a guy from Sardinia who had obviously in his lifetime hiked all the way from Sardinia, the 2,000 kilometers or so north, and was shot in the back with an arrow from one of the hostile Austrians at the time, and pushed into the glacial crack and froze there and laid there for 5,300 years. And so this body was full of Lyme spirochetes that look on the microscope exactly like the ones that we have now. But it was very clear that this guy was in his 40s, which was old for those days. He was in good physical health. He had some other things. He had multiple fractures that had healed. And he had some strange tattoos in the skin over the fractures. And I may get to you with that, so there actually was an old healing art practiced over 5,000 years ago in Sicily, where the healing of fractures was accelerated by putting certain symbols over the fracture. And there was a research project going at the University of Vienna where they actually took those symbols and tried it on freshly fractured people and found the same thing, that they could accelerate the fracture healing by 2/3 of the time. So instead of, like, let's say, taking 6 weeks, it only took 2 weeks to heal a fracture. Dramatic. Unfortunately, magically, after the guy published his findings in a very famous European journal called Raum und Zeit, he was found dead in his apartment. And so we don't know, was it foul play? Was it something else? But Ötzi was full of Lyme spirochetes. He was able to walk from Sardinia to the Swiss Alps to feed himself. He had a very sturdy, strong body. He was murdered. And so he is assumed that he was completely healthy in spite of his body being full of spirochetes. Now, if we see somebody with the Americanized version, or let's call it the weaponized version of Lyme disease, now, those people are down and out. They're in bed for years. They're hardly able to lift their eyebrow. They're very, very sick. It's a very, very sad state. And it's not comparable with the version of Lyme disease I was familiar with when I was a medical student already in Germany. It wasn't, of course, it wasn't called Lyme disease. It was called Borrelia. Yeah, it was a Borrelia infection causing some mild neurological problems. Now we see Borrelia infections with most severe neurological problems, but not only that, but also with immunological problems, digestive problems, fascial problems, visual problems, cranial nerve problems, dental problems, fertility issues, and chronic pain. People are severely disabled. And so what we see in the US now, and I have my practice on the West Coast in Seattle, so the weaponized version of Lyme we saw slowly since the 1970s, slowly spreading from east to west. And the first place where it arrived was the Los Angeles area. And then the second place it arrived at was just north of San Francisco, where there is now the highest, the Malibu Canyon in just north of LA. And then the Santa Rosa County in California, the most beautiful areas in California. Those are the ones most struck now also with the heat waves and the forest fires. And if there was, any paranoid ideas that this could be man-made, that somebody intentionally put the Lyme disease there, intentionally used the modification of geoengineering to dry out those areas, it must be like a really sick person, to take away the most beautiful parts of the US, to turn them into something else. But these are just, I'm just giving you some weird theories that people have come up with. But what you do need to know, when we talk about Lyme disease, we're not talking about the same thing. There is a smaller group of people affected with this most severely ill, and there is a larger group of people that have a moderate to mild illness with that. And it is probably not the same genetic gene sequence. If we could spend the money on every one of these cases to look at the genome of the bugs that are in there, we probably would find slight differences between it. Yeah, and so I will take you in my talk through different aspects of this. It's not a new talk. Some of you have heard me giving the same talk, but I give it you with the tweak of this time. And I hope that you learn something that's valuable. So the first aspect that we need to quickly go over is the main issue with Lyme disease is the primary presentation of Lyme as a neurological disease. Even though I said it's also a digestive disease, it's also a musculoskeletal disease, it's also an immunological disease, it's also a psychiatric disease. It has all these other aspects of it. But the key focus in the main conversation that we have right now is the neurological presentation. And so the question comes up, okay, the key piece here when people have brain fog and fatigue and have this weird sense of vibration in the body and the really odd things that never existed in neurology. And I had some pretty good training in that. These are all new symptoms that happened in the last 40 years. At the core of that is very clear, they're caused by inflammation, which we refer to as neuroinflammation. So what are the known causes of? Well, the first one is neurotoxins, that there needs to be some microscopic particles, whether they're peptides or other, mineral-based compounds, different molecules, informational molecules, or simple toxic substances. Neurotoxins have a wide variety. Many of them are caused by bugs. The most common conversation right now is the mold biotoxins. That sort of is a popular thing right now, that everybody has mold illness. We have the body on its own creates things that can be toxic, cytokines, IL-6 and others that can have a really toxic effect. We know there is foods that can have excitotoxins in them, substances that stimulate glutamate and other things in the brain and cause ultimately inflammation. Pathogens can have a direct effect on neuroinflammation. We know that the plaques in Alzheimer's disease, they consistently contain herpes viruses, but they also consistently contain aluminum, but they also consistently contain Lyme spirochetes. I'll show you some work on that. Head trauma can be the cause of neuroinflammation. The question is the inflammation actually the body's own way of healing the consequences of the trauma? Head trauma usually destroys some cells and some components of the structure of the brain. That's dead material that then lies around. And there's been a theory by the German physician Gerd Hammer that pathogens are allowed to move into this area to clean up the debris. And so the question there is, with neuroinflammation and head trauma, are the infections there secondary to the trauma? Or have the infections been there before and they're just growing? Or is it that the compromised tissue will be an ideal feeding ground for microbes? So the question is, are the microbes there to help, or are they there as parasites just benefiting from a situation? Autoimmunity certainly can cause inflammation. We know very well the cross-reaction of foods that you're allergic to. Like, let's say you're allergic to gluten, you eat gluten, and then your body creates antibodies against gluten. And there's many structures in the brain that look like gluten to your immune system, and so your immune system will attack those. There's many surface markers in different foods. There's the lectins, and there's other things that are also visible on certain cells of the brain. And so if your immune system becomes allergic to a certain food, that means you develop antibodies or cellular components that attack those parts, that will also attack those parts of the brain. That is very, very common. And that is certainly in my work using ART. This is muscle testing based system that I use diagnostically. We certainly make a very, very big deal that very early on in treatment of a chronically ill patient, we have to test everything that they're eating, but that includes the toothpaste, includes eye drops, cosmetics, shampoos, soaps, things they have on the body like jewelry, clocks, watches, piercings, tattoos, and then the clothing, things that are near the body. And we need to decrease the amount of things that constantly stimulate allergic reactions in the patient. We need to decrease that. There's an interesting thing that most people don't know, like when, for example, an infection stimulates your macrophages to become activated to fight the infections. That's called the M1 state, the activated state of the macrophages. The macrophage then has the job to release at the site where the foreign bugs have penetrated to release a whole bunch of inflammatory cytokines, both to attract other parts of the immune system to the area. Some of them are directly meant to kill. And the activated macrophages, the M1 state, causes local inflammation. And then the exciting thing is, if you want to heal the chronic inflammation, you have to move the macrophage from the M1 state to the M2 state, which happens through bioflavonoids like quercetin and luteolin and others. We get into that more in detail. The interesting thing is you cannot move the activated macrophage back to the zero state where it's just dormant. So you can either go into apoptosis and die, or it can be transformed from the M1 state to the M2 state. Now there's a problem. The M1 state, the inflammatory state, is actually protective of cancer. And when the macrophage moves to the M2 state, that is actually cancer causing. It's causing, it's helping with angiogenesis, the formation of blood vessels that the tumor tries to direct itself to. And so there's a tragedy here. You get to choose whether you're going to be neurologically inflamed and sick, or whether you have cancer. You can't have both. And I know you can, but it's not common. It's usually you go this way or you go that way. And then what we really need, like something in the bridge that makes the macrophages do the right choice for the body at that time. And these are the plant-based intelligent substances that come from simple things like parsley and chamomile and others. Aging can contribute to neuroinflammation, largely through the decline of certain things. We know with the older you get, like if you get a very high age, you will be deficient in vitamin B12. It goes down, biotin goes down, glutathione goes down, melatonin is hugely important, goes down. Okay, and then there is the vascular causes of neuroinflammation. We know from a really large variety of studies now that the COVID-19 is a bug that loves the inner lining of the blood vessels, and attaches, the spike protein attaches to the ACE2 receptors on the inside of the blood vessels. And that responds, the endothelium responds with severe inflammation to that, at least potentially. Good, and then there's the exposure to microwave, which is a really, really big deal and kind of silenced in the medical magazines. Most of the, well, I can give you the numbers, the cell phone industry is now 6 to 8 times financially bigger, stronger than the pharmaceutical industry, 6 to 8 times stronger. That's a huge number. And so the leaders in those industries have worked themselves into ownership of the medical journals and the scientific journals. And basically with the effect, you can't get anything published in a serious medical journal that talks about the dangers of microwave from the cell phone broadcasting. So we know some of the details of that, and I'm not a political activist, at least not today. And it's I would dare to make the statement here very clearly. All of you who listen to this have neuroinflammation right now, and all of you have to know that this is man-made and is not normal and is taken away from the beauty of your life. You have to know that. That's the choice all of you made to agree to that. Even just by the fact of using a cell phone, and it's a conscious choice to participate in life or to drop out. You participate under these conditions, but that doesn't mean you shouldn't resist, and that doesn't mean you shouldn't fight it. So here's the decisive article that I keep coming back to from Judy McCloskey. Judy was a student of Alan MacDonald, the gifted pathologist who was not working on the side of the government when he did the original studies on Lyme disease and the brain. So he basically, I get into his work in a moment, but Judy apprenticed with him, and then she became a professor in Switzerland. I think the University of Zurich, I'm not sure which one. And so she published this beautiful work where she put everything together that was known about Alzheimer's disease and did lots of dissections of brains of Alzheimer's disease. And she came to the conclusion that there is no, let's keep it simple, there is no Alzheimer's disease without Lyme spirochetes being present in the brain. And they're present exactly in the areas where the pathology is of Alzheimer's disease. And so her conclusions at the end of this beautiful, beautiful paper that she wrote, spirochetal infection occurs years or decades before the manifestation of dementia. That means all of my patients that are listening to this now, includes me, all of us who had Lyme disease, we are at risk of decades later going down with dementia. Now, the good news is that most of you who listen to this talk right now know that you have or have had Lyme disease, or that you did not have it, because you wouldn't be here if you wouldn't have looked into this. And so the good thing is, once you know it and do something for it, chances diminish dramatically that you will have that outcome. But for most of the population, we know most of the people don't have any chance to find a practitioner to diagnose them properly. They walk around with a bit of brain fog. They walk around accepting the beginning loss of memory. They're around accepting their digestive problems. They're around accepting the slow decline of their vision, the tinnitus, and all the other things that we know are linked very often as a consequence of Lyme disease. And so most people walk around with the symptoms, the milder version of Lyme, you're not the Plum Island version. And so, however, this thing is slowly nibbling away on the hippocampus and other structures in the brain. And slowly, there is a progressive destruction of pathways in the brain and parts of the brain that may be reversible to a certain degree, but certainly not after 60 years of not attending to it at all. Okay, so the last sentence here, yeah. So she says, if it's true that Borrelia burgdorferi is present in the characteristic areas of the brain linked to Lyme disease, then it is very likely that prolonged antimicrobial treatment, similar as in syphilis, should also be able to prevent this outcome from it. And so I put this at the beginning of my talk because basically you have a choice. You know, most of you who listen to this already have either recovered to a degree or are feeling pretty well, because otherwise you would not have the energy to sit in front of the computer for an hour to listen to something, certainly not something I'm saying. And so just make a decision. You know, if you have any symptoms, follow the advice that I'm giving you at the end of this talk, whether it is today or next time. We have to see how far we get. So here is this beautiful work of Alan MacDonald. I know some of you have seen this before, but basically he looks at the hippocampus. So the hippocampus is that very small part of the brain that's associated with the center of what we call memory. Yeah, that's the cells in the hippocampus are hugely important for memory. We know the hippocampus shrinks under stress. It can really burn down. People that come back from Afghanistan today, they have a severely shortened, smaller hippocampus than those of you who had the fortune of not having to go there. Some of that, it seems to be reversible, that those cells that are lost come back, but some don't. And so because it's associated with memory, and the primary complaint of chronic neuroinflammation and Lyme disease is increasing loss of memory, he looked at the cells, the nerve cells in the hippocampus, now admittedly of patients obviously that died from this illness. And so what you see down here, this is the actual axon of a nerve in the brain. And this other thicker layer around it, this orangey structure here, is the myelin sheath. That's basically the insulation around the electric cable. And embedded in the myelin are the spirochetes. Yeah, here's another view of that. Yeah, here's the axon of the nerve, the yellow thing, and then the greenish orangey thing here. That's the myelin sheath. And embedded in the myelin sheath is the spirochetes. This probably should also then not come as a surprise to you, that we found, you know, in the work that I do, that pretty much at least 90% of MS patients, we find spirochetes in their central nervous system, you know, because in the key piece of multiple sclerosis is that this myelin sheath gets attacked by the immune system as if it was the enemy. And of course, because the myelin sheath is where the Lyme spirochetes are living, this myelin is no longer recognized by the immune system as something that should be part of the structure of the body. And the immune system goes after it with a vengeance to destroy it. And it does destroy it, including the spirochetes in it. But then you end up with a nerve, an electric hot wire that doesn't have any insulation around it. And then you get all the symptoms of MS. I would dare that if there would be fair financing of studies, that we would find the same in autism, a lot of cases of autism. We would find the same in a lot of cases of Parkinson's, just in different parts of the brain. And we would find it in many neurological illnesses. Okay, well, here's another picture. You know, so what he did here, what Alan MacDonald did, he basically took the brain of a patient who died, suspected having Lyme disease, took the brain, put it in a blender. I'm oversimplifying here a little bit, and then put that extract of the brain that represented all of brain, you know, so on a glass plate, put some dye on it, a DNA strain that's very specific, dye that's very specific, only marks bugs that have the same exact DNA part as Lyme disease has, and marks those. And so he found in the brain extract of everyone, not a few, everyone who died of Lyme disease. You could do the study and could show that there were Lyme spirochetes in there. Conventional medicine argues the point, okay, he did this on his own money, Dr. McDonald, right? And you should think it should stimulate like 1,000 universities in the world to repeat the studies. And guess how many have repeated that work? Your guess is right. Nobody has. And so if this is true, what McDonald says, we have the work lined out for us, because it means we need to come up with a diagnostic procedure that can look inside the brain to see if this is present, right? Because can you look at this? This is a brain extract. This is not the blood of the patient. And so let's look at this picture, right? This is spirochetes embedded, firmly embedded solidly in one of the body's own tissues. You're not looking at the blood. And where does your physician look for the Lyme disease? It looks in the blood, maybe in the urine, yeah? But this ain't the blood or the urine, this is a nerve. And so in order to really obtain a clear-cut diagnosis, you need to look inside the brain, inside the nerves. Now, I don't want to push the issue, but I developed a technique called autonomic response testing that allows us to do a non-invasive biopsy of the brain. It takes less than 2 minutes to do this test, and I can tell pretty much everybody if you got Lyme spirochetes in the brain or not. Yeah, that's called autonomic response testing. That can be learned. There's an online courses, offered by Klinghardt Institute. It's called ART1. I encourage you to enroll in the course. You're going to learn a lot. But I'm not here to talk to you about the teaching of that. I want to introduce you to what is known about this illness that's less known. Yeah, most physicians that listen to this did not know this. Good, and here's like some of his studies. You see the first one was actually published in 1986, the very dawn of Lyme disease, in JAMA, the Journal of the American Medical Association. That means it's not, an unknown paper. That's the thing every physician gets for free. By the way, I have not gotten my free copy in over 10 years. I'm shunned by the medical community, even though I'm licensed in the state of Washington. But that's another issue. So this first study, Borrelia in the brains of patients dying with dementia, the pictures I show you were from there. The second one, is 20 years later. It's sort of like, okay, what did he do in 20 years? Well, the first journal is read by pretty much every physician in the US. The next one, he only could get it into Medical Hypotheses, which is a wonderful paper, but read by only a few hundred people, maybe 2,000. And so here the name Plaques of Alzheimer's disease originate from cysts of Borrelia burgdorferi, the Lyme disease spirochetes. So he went into the plaques, the hallmark of Alzheimer's disease, these strange neurofibrillar tangles, and then with this shell around it that we call plaque. And he biopsied the plaque, and this is the pictures that you saw, and found it full of spirochetes. And then the last one here is an interesting one. Again, 2007, so 21 years after his first paper, where he actually looked at how spirochetes move inside the nerve. They follow the myelin sheath and burrow themselves, through the myelin sheath and move along the nerve. And then, the nerve has a synaptic clefts where the nerve ends. And then the only propagation of impulses is through these neurochemicals that are released into the cleft and then picked up on the other side, and then the impulse travels on. And he discovered in this study, is published, that the spirochetes, they move along the nerve, they come to the synapses, on the backside here, and then they travel through the membranes, through the cleft, into the next nerve and travel just peacefully along the nerve. So they can move freely in the brain, infecting one nerve after another, leaving their progeny behind and slowly settling in larger and larger parts of the brain. That is something you have to know when you're dealing with neural Lyme. That is where you need to have your eyes, this is where you need to get to with medicine, we need to get to with your treatment. And, and before that, you have to get there with your diagnostic tools. And the only tool I know that can really definitively say where in your brain you have what is our autonomic response testing. I may give you a lecture on that, because that, I think, is something overdue, that I square with you. Many of the people listening to these talks used to be students of mine that are familiar with ART, but now it's grown beyond that. Where a lot of you watching that never heard the word ART and autonomic response testing. Okay, let's talk briefly about the bull's eye rash. The bull's eye rash. I am very sure that this is true, what I'm saying. First of all, you find it in less than 25% of people that have acknowledged full-blown Lyme disease. Only less than 25% ever had a bull's eye rash, period. That's number one. Number two, I found very, very clear evidence that the bull's eye rash is a second strike phenomenon. This only happens in people that already have pre-existing spirochetal illness, maybe with mild symptoms or maybe even no recognizable symptoms by the patient, but they only get the bull's eye rash if it's a second time that they are stung with the same or similar spirochete. So I can't prove this to you now, and I'm not going to take the time, but I'm observing patients now for 40 years, being quite Lyme literate, and I can tell you that this is true. Probably one day or another it will be proven, if there's more research money poured into this, which we'll hope. When we're thinking of how much money was spent on the AIDS pandemic, the relationship of money spent on Lyme disease compared to AIDS to Lyme is about 100 to 1 in terms of finances on research. But the incidence of Lyme in relationship to HIV is 100 to 1. So it's a ridiculous, disproportionate amount of money deviated to research in one area that only, is interesting to a smaller part of the population, whereas research money that's given to Lyme disease, that's of interest pretty much of everyone alive. And so there is some injustice in that, and always happy to point that out. The numbers, I think, are not relevant. There's different types of statistics, and every time you look, there's a new statistics using different criteria, because there's still no agreement of how to best diagnose Lyme disease. I think those of you who are Lyme literate, you're tired of the old argument, but the CDC still suggests to do the ELISA test first, which is a highly insensitive test, and only if that's positive, then to do a Western blot test, which is a lot more sensitive. It's the wrong way around. Everywhere else in medicine, you do the most sensitive search test first, that broad-based, that tests for many different things. And if that's positive, then you hone in on a single ingredients of it and use other tests that then cannot define what you find there. So the proper way for us to diagnose Lyme disease, to do on the first trial, to use the most sensitive test that's available right now. So it used to be the Western blot, then came Armin Schwarzbach with Armin Labs, with the LTT ELISpot, which was much more sensitive. And so now we have a whole variety of tests that can get a bit confusing. We have Joe Boroscano's culture test, which takes a few months, but it's very definitive. We have the tick Plaques test, that's a PCR-based test that's less sensitive, but it's a wonderful thing with it. You can test for dozens of different similar bugs and have a much more, capturing much more, because when you do the Western blot or more specific test, you test for one small group of spirochetes. But as we know now, there's lots of mutation and lots of similar forms causing the same illness. That could be outside this, there could be over here, or could be over here. And so to inform yourself, and I know the leading lab in the US still is IGeneX. I prefer the German lab, Armin labs. It's not because I'm German, but I do understand the need that we need to use the most sensitive test, not the test that pleases the government and the insurance companies the most, but we need to have the test that's most fair to the patient. That if you have symptoms and they're caused by Lyme disease, you should use the test that has at least a 96% chance of finding it. You should not use the test like the ELISA test that may have a 60% chance of finding it, because the other 40% mean you're told it's not Lyme disease, you're not getting the treatment, and you're slowly left to die on your own without any help from your insurance company or from the social services or anybody. I know some of you listening to this are in that position, or at least know of people who are in this position. We've, in the crisis of the last year and a half, we've seen a lot of abuse, of false science, of fraudulent science. We've seen a lot of science, says that, for example, the wearing of the mask is useless, and then it's translated by the government, you have to wear masks because of the study. And you see a lot of cognitive dissonance. And most of us Lyme literate practitioners have seen this now for 20 or 30 years and are not surprised by what happened in the last 2 years. But it's still shocking, to see the lack of common sense in pretty much anything surrounding the current situation. And so, but the worst thing for us is that the eyes are so much on this viral illness. And the reason I give this talk today, and as it turns out next week, is that I want to redirect your eyes to what is actually much more common and much more needed at this time. Here's a nice picture of the electron photography of a spirochete. The spirochete, interesting with this form, it moves like a corkscrew through the tissues. And somebody did a study, a mathematical calculation, was like if you would inject the spirochete into the tongue and it would travel to your feet, how long would it take? Well, there were different numbers given, but it's only, at the end of the day, it would only be a few seconds with the incredible rapid speed. And this is not traveling inside the blood vessels. This is traveling through the connective tissue. And spirochetes are smart in order, if you want to build a tunnel, through a mountain, and it's a mountain of granite, it's a lot of work and will take a long time. It would be much nicer if it would be a mountain that is at that place full of clay and some soft material, and you could drill easily through it, right? And so that's exactly what the spirochetes recognized, sort of like drilling themselves through connective tissue is really hard work. And so what they do, they're turning on a system of enzymes that we all have. They're called metalloproteinases. And proteinase means it's a protein splitting, protein softening enzyme. And so they trigger our own body to do that work for them. So it turns the connective tissue, which could be a little bit more like granite, in the comparison. They're making your connective tissue soft. And many of you women are aware of that the moment you got Lyme disease, your skin lost its tightness, your connective tissue lost its tightness, it started sagging, it started becoming softer and more flabby, and you were upset about it because you were only 30 years old or 40 years old, and and you're taking care of your body, you try to exercise, you try to eat good, and still you see your body slipping away from you. Yeah, and that is this nasty bug initiating this cascade of enzyme events that softens your whole tissue. So this thing can travel left and right within a few seconds through your system, in the blood, still because of its ability to move. The spirochete can move 2,000 times faster than the white blood cells that are supposed to catch it. It's sort of like you being on a bicycle trying to catch an airplane. Yeah, and that you have to know those numbers. This is like an unusual task we're up against in the treatment of Lyme disease. That's why it's been so difficult, and not the universities not getting the monies for research to look deeply into this. Where sort of things are moving very, very slowly. We know more about SARS-CoV-2 after a year than we know about Lyme disease after 45 years. Yeah, that's a sad situation. Okay, so now we're getting a bit more to the nitty-gritty of it. So looking under the microscope, you see this funny little seed-like structures on the outside skin of the spirochete. Or on the right side, they show us black dots. On the left side, there's these little blisters. They're like seeds that contain the entire DNA of the bug, so they're like babies ready to go. And so I just tell you the whole rest of the story. So when you actually threaten the environment where the spirochete is, let's say you inject ozone or you put the patient on antibiotics, the spirochete is very, very vulnerable. The rest of the worm-like structure is very, very vulnerable to any chemical, to ozone, to hydrochloric acid, to HOCl, to chlorine dioxide. It dies pretty much immediately, but what doesn't die are these little cysts on the side. Those have been tested. They have been put into hydrochloric acid for a couple of hours or days, and then, assuming that it will completely annihilate what's in there, and then these seeds were put onto a culture plate, and lo and behold, within a few hours, happy spirochetes slip out from it, ready to go. They did the same by putting these cysts into a flame. I forgot how long it was and what the temperature of the flame exact was, but I put it in a flame, which pretty much in the world kills everything and takes the life out of everything. Okay, I did that, and I put the seeds back on the culture plate, and living spirochetes slipped out. Now, the point I'm trying to make here, if you think you can take 100 milligrams of doxycycline, which distributes itself over whatever 70 or 75 kilograms of weight in equal distribution, that you reach concentrations that will destroy these cysts, you're dreaming. Yeah. So far, nothing has been found reliably destroying these cysts. There is assumptions with grapefruit seed extract. There's assumption that tinidazole or flagyl metronidazole can destroy the cyst. There's assumptions that N-acetylcysteine may dissolve the cysts. Well, they probably do, maybe in vitro, an experiment outside the body. That could be that occasionally that works, but I have great doubts. And so I give you sort of my secret here, so the top secret of my Lyme treatment. I've realized that it's probably not possible to destroy these cysts, but what we can do, we can bait the bugs that are coming out of these cysts. We can present an environment, a microenvironment to where the cysts are located and seduce them to hatch out into the Lyme spirochetes and then kill them, because the young spirochetes do not have the ability to make these cysts. They take, I don't know if it's days or weeks, it takes some time to be able to create these survival capsules that are sitting on their skin. And so if you can catch the spirochete while it's hatching out, you're in a winning situation. And the food that we found that helps them to hatch out is called hyaluronic acid. That is why spirochetes love to live in certain body compartments like joints and tendons, tendon sheaths, the palmar fascia, the teeth, close to the teeth, the dental ligaments, in the eyes, the mouche rouleau, the floaters that you have in the eyes. There's certain tissues in the body that are high in hyaluronic acid, and that's where they live because they're addicts. And so what we do, we give people sublingual hyaluronic acid that's easily absorbed through the mucous membranes and then floats around in the bloodstream. And the bugs that sense the stuff coming through, they're slipping out of the cystic form, come out and go after the hyaluronic acid that you give them. And if you follow that with an appropriate antimicrobial, you're succeeding. You're depleting the body of these cysts and of the spirochetes. And why is that important? Well, the agreed upon thing is that the cysts themselves are not toxic. They're not alive yet, and they don't have any big biological consequences. They're not consuming your nutrients, your oxygen, your water. They're just lying there. However, the immune system is not happy about it, and the immune system in a lot of people starts to attack every tissue where these cysts are. And so this is why, and I will show you some of the science in a moment, when you treat a patient underdosing with antibiotics, you're forcing the spirochetes to give up their body and move into the cystic state. They're usually, the cysts are then embedded either inside the cell or cell wall. They're attached to structures, very often in biofilm. And so they're in a, okay, my PC is running out of electricity any moment. I don't have a charger here. I'm somewhere in the wilderness away from home. And so the spirochetes they cannot be killed in the cystic form. The cystic form causes the immune system to go wild and attack every tissue in the body that has these cysts in it. And that is part of what we call autoimmune disease. Yeah. So what happens, you undertreat somebody with Lyme disease with lower dose antibiotics or with certain herbal compounds that are not quite hitting it, but it forces the spirochetes to give up the body. They lay these cysts or eggs, if you want, into biofilm, into membranes, where they're safe, where they can wait for a better day. And when the better day comes, they're hatching out. And you create the happy day by giving them hyaluronic acid. A lot of them come out. You follow that with a compound that kills them. And that has been a wonderful strategy. And I'll give you the details of that later. I do not use antibiotics for that. I use antimicrobial herbal compounds that have been proven to do this job. So here's sort of like a little bit of why have we gone away from antibiotics. Well, okay, admittedly, study of the early treatment, so basically they showed that 1/3 of patients that were treated with long-term antibiotic course were still ill 6.5 or 6.2 years after antibiotic treatment. So basically, antibiotic treatment failed in at least 1/3 of patients. And then the next study shows that 2/3 of patients, this is now stepping it up here. This is the same year, but in the same year, another study showed that 2/3 of patients were still ill 3 years after antibiotic treatment. And now comes the worst one, is the study from 2005 that shows that the patients that were treated for Lyme disease with antibiotics, that this group, so they had like one group of over 500 people who were treated with antibiotics and another group that was not. Both of them had Lyme disease, and the group that was treated with antibiotics had more fatigue, more musculoskeletal pain, and more neurocognitive difficulties than the untreated people. And that is like, what's the point, with that? Of course, when you look at the at the details of the studies, they used way too low doses of antibiotics, way too short. But how do you know when you've done it enough? So should you really go for 3 years, like some people do, or at least 6 months, or at least 3 months? That is still not cleared if you go the antibiotic way. And so the last thing I want to show you is this, that makes the point maybe a little bit better. So basically what they did here, this 2011, for first of all, they're looking at these cysts, now called round bodies, and stay with the term round bodies, because when you say cysts, you will be discarded by the scientists around you. That's why I like to say cysts, to don't take me too serious. So basically, what they speculate in the first part of the paper is, why are people not improving with treatment? And they say, well, the recurrence or the resistance to treatment may be due to the formation of these round bodies or biofilm colonies. In biofilm, you can have both the round bodies or short sections of the spirochetes. And then they found that when you treat the fresh Lyme patient or the chronic Lyme patient with doxycycline, yes, 90% of the worm-like structures disappeared. But the number of cysts that were seen before have doubled. So the spirochetes withdraw their physical form and mutate, transform it into the cystic form, which is not possible to destroy. There is, at the end of this article, the speculation that tinidazole had some effect on it, but not enough. The conclusion: persistence of viable organisms and round body forms and biofilm-like colonies may explain treatment failure and persistent symptoms following antibiotic therapy of Lyme disease. So my comment is pretty clear here. When Lyme is undertreated with doxycycline only, there is a likely chance that permanent round bodies and biofilm are formed, being later the cause of autoimmune diseases, which rarely responds to treatment with antibiotics. I like to say here, this is not to brag, but I did my thesis on autoimmune diseases, and I defended my thesis, in 1979. So I've been onto this like for at least longer than some of you have, looking at autoimmune disease and the true causes of that. At the time, we already knew there were infections involved. We also knew there were certain heavy metals involved with it. And so it was only in the 1980s and 1990s for me that came together what is going on here. So I know I haven't given you much yet. So this was just the first part of my little Lyme talk that I like to give you for the next few weeks until we're through this and we come up with my very, very established, solid treatment suggestions that work. And I will update you. I will include the low-dose immunotherapy from Ty Vincent, and I will include the work with disulfiram to see where these different things all have their place. But we have, I have practitioners all over the world that follow my lead, and we have patients all over the world, and we have pulled a lot of people in the world out of the deep muck of Lyme disease. And so I want to share that with you because it's simple. Most of my treatment suggestions do not require a prescription pad. So I'm giving this basically to the population. So as a self-help tool that is safe and it's in most cases very, very effective.